Hello and welcome back to Mr. Powers Teaches Algebra. What are we talking about today? We're getting into exponential functions. You'll love to see it. And so what's an exponential function? Well, to put it plainly, it's a function that looks like, what? Come on now. Looks like this. There we go. That's an exponential function. You may see it also as this. Sometimes we have it say, there it is. You might have it say f of x equals a times b to the x. But, and the a is going to manipulate the graph a little bit. And we've seen that kind of stuff before, so we'll just go with this. This is going to be our mother function, our parent function. F of x equals b to the x. Okay? That's going to be an exponential function. We have a couple restrictions on b. B has to be greater than 0, no negatives. It cannot be equal to 0. That'd be silly. Why would that be silly? Well, what's anything? So b is 0. What's 0 to the 5th power? It's 0. What's 0 to the 8th power? It's 0, right? 0 to anything is 0. So, but except for, of course, 0 to the 0, I don't know, right? So let's not mess with 0 as b. The base can't be 0. B is not going to equal 1 either. That's another obvious one, because what is, let's say, 1 squared? It's always 1. 1 cubed is always 1. Just like 0 raised to anything, 1 raised to anything is 1. So we're not going to have that kind of junk. All right. Now that b, is going to be our base, and x is any real number. X, no restrictions on x. It can be anything, any real number. So not necessarily a complex number. Any real number. All right, and that'll do it. Okay, so now that we know what an exponential function is, we got to know what they look like, right? I think that's what we really want to know. Let me see. What else did I want to talk to you about? We went over that. I guess we could talk about also, right? It can't be 0. It can't be 1. Why can't it be less than 0? Why is it greater than 0? Why is it always positive? Well, really, what's wrong with negative bases? So a good example might be f of x. I'm going to borrow one from our notes. Is negative 4 to the x power. So in that case, f of, let's say, a half. It's a great example. F of a half would be negative 4 raised to the 1/2 power, which we all know is the square root of negative 4. That's going to be super weird. That's, 2i plus or minus 2i? Yeah, we don't want to do that. Some issues there, right? It's not a function anymore. Is it? It's definitely not a function. And then, because 1x is getting us 2 different y's, that's not good. And then, on top of that, we're getting not real numbers. What else here? What if I had f of 2? That's negative 4 squared. That's okay, but that's 16. Now, so we're jumping around to positive to real numbers, to irrational, complex numbers, like imaginary numbers. It's a mess. So we're not going to mess with any negative bases. That is not going to be good, right? Because we go 2 and then what? 2.5. Well, okay, what's that? F of 2.5. We don't want to mess with that, right? So that's another thing. We're going to just make sure our base b is greater than 0 and not equal to 1. So that's very important. Okay. So now what would be really good is to maybe, since we got a few more minutes here, I don't know, it's a 5-minute video. We can go longer. let's look at our graphs. I think that's what I really want to do. So I have f of x equals 2 to the x, and I have g of x equals 1/2 to the x. So I got one where the base is greater than 1, and one where the base is less than 1. And you can see we have this relationship here. They look the same, and in fact, they are exactly the same, except, right, at -2, 4, instead of that, I got 2, 4. They're flipped over the x-axis, and I can show you that. F of x equals 2 to the x, that's this green one. I got a red one here that'll be the same as the blue. 2 to the negative x is the same as 1/2 to the positive x. See that? It overlaps that one. And why is that? That's pretty obvious. 1/2 to the x. And here's the reason why. So let's take a look at that really quick. Okay, because that's worth taking a look at. 1/2 to the x. So 1/2 raised to the x power is the same as 1 to the x over 2 to the x. Well, 1 to the x is nothing, so it's always 1. So it's really just 1 over 2 to the x. Well, that's the same thing using our properties of exponents as 2 to the negative x power. So when you have a fraction less than 1, something like this, raise x, 1 over 5 to the x, 1 over 6 to the x, right? It's this kind of thing. If I had 1 over 5 to the x, that's the same. It's equivalent as 5 to the negative x. So that's an interesting little property with these guys and their graphs, right? And so we get these reflections over our y-axis. And so that's something we want to notice here. 2 to the x and 1/2 to the x is a reflection over our x-axis. Because when you have, you change the to the opposite of x, right? X to negative x, that does that reflection over the x-axis, and that's nothing new. So we have that. And the very last thing I want to show you for this video, as we look at what an exponential function is in our mother function. So we're just saying, hey, here's our basic one, 2 to the x. That's really the one that we're like saying, you know what, you got to know what that is. So what do we notice about 2 to the x? Let's go ahead and get this off. Oh, and the table here. Let's delete that, hide points. Okay. So -3, 2 to the negative third, that's 1 over 2 to the third, that's 1/8. So 0.125, we got it right there. If I can get it, there it is. 1 over, so if it's -2, it's 1 over 2, or it's 2 to the -2, so that is 1 over 2 squared, 1 over 4, that's 0.25. 2 to the -1, that's 1 over 2 to the 1, that's 1/2. So we have these points. I just want to show you that. 0, 1. That's an interesting one. Whenever x is 0, y is 1. That point is always there. That point is always there. Okay? So I'm going to just do this really quick. Since we're talking about the points and we're plotting these points, we can see them. And we can see the shape. 0, 1 is something we need to notice. 0, 1, that will always be there. So there's another property that we have. 0, f of 0 is always 1 if we're dealing with an exponential function. Look at all of these. Go through 0, 1. Go through 0, 1. We can try another function. Let's say f, g, h, I, j, k, I don't know, k of x. Let's say k of x is equal to, I don't know, 5 to the x. Say 5 to the x. Look at that. And it's still going to go through 0, 1, no matter what they do. Why is that? Well, if our function is of the form f of x, right, is b to the x, it's in this form, then what happens when you have f of 0? It's b to the 0. And we know that anything raised to the 0 power is 1. So you're always going to have f of 0 equals 1. You're always going to have that point, 0, 1. All right. What's another thing we need to notice? Another thing we need to notice is that all these graphs are all positive. We have no negative values and it doesn't equal 0. Even this one, like as I go back here and I get closer and closer and closer and closer, if I zoom in, zoom in, zoom in, zoom in, we can start to see, well, at least with this one here, with our green one, 2 to the x, it is above the x-axis. Our orange one is very closer, but it's still just barely hovering above the x-axis. Let's see, anyway. Again, I'm not getting there, but trust me. It's very close to the x-axis, but it is not touching it. All right, right here. It's always, if I zoom in, see there, it's getting closer. I can zoom in some more. Nope, not touching. It never ever touches it. And why does that? Why is it that these graphs will never touch the x-axis? They can't equal 0. Because if you think about it, our base, 2 raised to the some power, remember, you're multiplying 2 times itself so many times. Or maybe you're getting something like 1 over 2 times itself so many times. No matter what, those are positive numbers. You can get close to 0, but you'll never reach it. So these have asymptotes at y equals 0. Sorry. They all have asymptotes at y equals 0. So we get in these properties here, right? Let me see. So, yes. So let's just show you those real quick since we talked about them. I want to show you these properties here. There we go. The graph of f of x, again, assuming we're dealing with a basic exponential function, something in this form, b to the x. F of x equals b to the x. The graph of f of x will always contain the point 0, 1. We saw that. Our values are always greater than 0, and we have an asymptote. I'll mention that. We have an asymptote, a horizontal asymptote at y equals 0. That's something to notice too. If it's between 0 and 1, the graph, if b, our base, is b to the x, will decrease as we move from left to right. That is because, like the graph 1/2 to the x, if we're looking at that one, right? You're raising 1/2 to a power. As those powers get larger, you're multiplying a half times itself over and over again. You're getting smaller and smaller numbers. That makes a lot of sense. And likewise, if b is greater than 1, like here, you're multiplying something greater than 1 times itself over and over again. It's getting larger over and over again. So we're going to be going the other way. If the base is greater than 1, it increases from left to right. All right? And that is it. And then this last property we haven't talked about yet, but we'll get more into it, is if b to the x equals b to the y, then x equals y. And that tells us that it is well defined. Okay, and it's a function. And this is a function. So if b to the x equals b to the y, x must be y. So that is, and that's pretty intuitive because we dealt with exponential functions before, but we will go into that more later. I think that'll do it for this video. We're at 15 minutes, and I don't want to make it too long. I know it's rough. So that's enough for now. We talked about a little bit about what these are. and all these properties. Okay, these are important to know. They're important to get down. So that will do it. But if you want a little bit more, if you need a little bit more, I will go ahead and talk to you a little bit about that table we had for f of x. And f of x was 2 to the x in this case. So right here is 2 to the negative 2, which is 1 over 2 squared. That's 1/4. Likewise, this is 2 to the negative 1, which is 1 over 2, which is 1/2. That's 0.5. There it is again. There's our 0. 2 to the 0 is 1. 2 to the 1 is 2. 2 squared is 4. 2 cubed is 8, and so on. So just if you wanted a little bit more detail there. So that'll do it for this video. Exponential functions. We know what they are. We know the basic function, what it looks like now. Now we can use our other knowledge to graph or sketch more of these, which is really cool. So until next time, enjoy doing math.